Hello, Algebra 2 folks, and welcome to 7.5 Properties of Logs. Today we're going to learn to expand and condense logs. These properties will help us later when we solve equations using logs. You'll need your notes and a pen or a pencil, and we will get started. Alright, so I want you to put down these properties. The first property is log of a product. The second property is log of a quotient. And the third property is log of something to a power. Now what I want you to do is I want you to write down these properties and we're going to talk about them. But in a minute I'm going to explain to you why they work the way they work. So the first property we're going to talk about is the property of the log of products. So if I have a log to any base of a product, okay, product means I'm multiplying. That's going to equal the log of the first product, part of the product, plus the log of the second part of the product. So the multiplication now becomes an addition. And so this is what we call expanding. When we start with something that's small and condensed, and we get something that's expanded. The second property is log of a quotient. A quotient means I'm dividing. So here I have a quotient and a division. A is the numerator, B is the denominator. Log of A over B turns into log of A subtract log of B. So the division becomes a subtraction sign. Now if I have a log of something to a power, I start out with log of A to the B. This is a power, A is the base, B is the exponent. The base stays log of A, but the exponent becomes a multiplier. So it goes out in front as a multiplier. These are all being expanded. Okay? We can also include the ln. So whether I have a log of base 7, or base 10, or ln, which is the log base e, this works for all logs, no matter the base. Now you're probably thinking, what? Why? Okay, well remember, what does a log do for us? It helps us isolate the exponent. So if we think about exponent properties and exponent rules, hopefully, these properties of logs will help you make sense of them. So when we add exponents, when do we add exponents? Well, guess what? When we have a product. So when we have a product, we add exponents. Well, when we have a product in a log, we can expand that to being an addition. Okay? When do we subtract exponents? When we have a quotient or a division sign. Same with logs. Okay? And when do we multiply exponents? Well, you guessed it. When we have a power to a power. So logs are essentially exponents, right? Because we use them to isolate exponents. So the properties we would use in exponents are the properties we would use in logs. All right, so now that we kind of understand where those properties came from, let's see if we can use them to expand a few examples. So if I have log base 3 of a product 4 times x, I can expand that into log base 3 of 4 plus log base 3 of x, because a product becomes an addition when we expand. If I have log base 10 of 6 divided by y, I have a quotient. So a quotient says you take the log base 10 of the numerator minus log base 10 of the denominator. The 6 is the numerator, the y is the denominator. And so a division becomes a subtraction. If I have ln of x squared is considered a power. What do we do with powers? We multiply them. So we take the power, or the exponent, we put it in front as a multiplier. So this would become 2 times ln of x. Okay, let's try a few more. Log base 4 of 3x squared. Oh, now I have a quotient, a product, and I have a power. So sometimes you can have more than one within a problem, but you have to make sure you take care of both. So the first thing I'm going to do is take care of the product. So log base 4 of 3 plus log base 4 of x squared. Now my log base 4 of x squared, which is the power, now becomes 2 times log base 4 of x. So the 2 becomes the multiplier. Now that is the final answer. The ln of 6x divided by y. Well, this says the ln of 6x, and divided by, or division, is subtract ln of y. Well, within 6x, I have a product. So I really should say ln of 6 plus ln of x, subtract ln of y to get the full expanded answer. Okay, now that we've expanded, let's see if we can go backwards and condense. So I have log base, if I don't have a base, it's base 10. And both of them are base 10. They have to have the same base in order for us to condense them and go backwards. So I have a subtraction, and subtraction means division. So 7 is my numerator, x is my denominator, and all together they would be in 1 log base 10. Okay, I have 2 ln of x plus ln y. The 2 is a multiplier. That becomes a power plus ln of y. Now I have a plus, which means x squared times y, and that's a product, so it's ln of x squared y. So I'm going backwards. What would it have started with to get the answer we began with? Okay, so here's another one, condense. It has a bunch of things, so let's do one thing at a time here. We have 3 times, so 3 is a power. So we have log base 2 of 5 cubed plus log base 2 of x, subtract 4 times, we have another power, log base 2 of y to the 4th. Okay, so we've taken care of all our powers. Now we have a plus, which means product. So we have 5 cubed times x, and then a subtraction, which means divided by y to the 4th. All of that log base 2. So I could even simplify that a little bit more by saying log base 2 of 5 cubed is 125x all over y to the 4th. And that would be my final answer. So why are we learning this? Well, we are learning this to help us solve equations. So the last section of this chapter is learning how to solve equations. And remember, when we're solving equations, we're putting all our knowledge together that we've learned throughout the chapter to be able to solve the equations. And if you look at this equation, the one thing that I can think of doing right away, being that they both have the same base of a base 10, and I see a subtraction, is I would condense these down using the quotient property. And then by putting them together and using the quotient property, then I'll be able to use other steps to be able to help me solve this equation. But today or tomorrow, our focus is to be able to condense and expand. So thank you for taking good notes, and we will come back tomorrow and practice condensing and expanding.